We are starting now question number 9 of this M1. 3 points A, B, C lie on the line of the greatest slope of the plane inclined at an angle of 30 degrees to the horizontal, with AB is equal to 1 meter and BC is equal to 1 meter, as shown in the diagram. A particle of mass 0.2 kg is released from rest at A and slides down the plane. The part of the plane from A to B is smooth and the part of the plane from B to C is rough with a coefficient of friction mu between the plane and the particle. Given that if mu is equal to root 3 over 2, find the speed of the particle at C. And the second part of this, given instead that the particle comes to rest at C, find the exact value of mu. Since it is a plane which is inclined at 30-degree angle to the horizontal, from A to B, its distance is 1 meter and B to C, the distance also 1 meter. Where AB is smooth, so that is what coefficient of friction between these two is 0, and B to C is rough, so that is why its friction is not equal to, coefficient of friction is not equal to 0. And now we have to calculate the speed at C there. So for the speed at C, we first resolve the forces into components because the mass of that particle is 0.2 kg. So for this particle A, its normal reaction is R and it is mg cos theta and this is mg sin theta. And here from A to B, distance is 1 meter and the coefficient of friction is equal to 0. Then from B to C, distance is also 1 meter, but the coefficient of friction is equal to root 3 over 2. We will first calculate the speed at B and then this at B position is V will become initial velocity and we are going to calculate the speed at C here. So this is the working process that how we solve it. We know that driving force minus resistive force is equal to net force MA. So here driving force is mg sin theta for particle A minus resistive force is F, which is 0 because coefficient of friction is 0 there. And that thing is equal to mass of that particle, that is 0.2 into acceleration A there. So first we are going to calculate this A for this part. M is 0.2, G is 10, sine of 30 minus 0 is equal to 0.28 R. 2 into sine of 30 is 1 over 2 minus 0 is equal to 0.28 R. 1 is equal to 0.28 R. A is equal to 1 over 0.2, which is equal to 5 meter per second square, is the acceleration of the particle from A to B there. Now, distance is also known to us. So we can use this equation of motion v square minus u square is equal to 2as, where v is going to be calculated. U is 0 there because it started from rest at the position A, and then 2 as this acceleration is calculated as 5 and distance is 1. So v square is equal to 10, or v is equal to square root of 10 meters per second square. But this is the speed at B there. Same speed at B will become the initial. That thing is equal to root 10. Now from B to C, this is the motion of that particle from A to B. And now we are discussing the motion of this particle from B to C. From B to C, the driving force is still the same, that is mg sine theta minus f is equal to ma1, because it is now moving with a different acceleration there. So m is 0.2, g is 10, sine of 30 minus f is mu r is equal to m into a1, r 0.2 into 10 into sine of 30 is half, minus mu is there, that is root 3 over 2 into r, that is mg cos theta, and that thing is equal to ma1. So this m, this 0.2 and this m is going to be cancelled out. So a1 is equal to 5 minus root 3 over 2 into 10 into cos of 30 is also equal to root 3 over 2, and that is equal to a1. So a1 is equal to 5 minus 10 into 3, 30 over 2, or 4. So that thing is equal to a1 is 5 minus 7.5, that is equal to minus 2.5 meter per second square is the new acceleration of that particle from B to C there. Now we are going to find out the speed at C. We know that again we will use this equation of motions. V square minus u square is equal to 2as. V at C is going to be calculated where u is equal to initial speed of this. So that thing is equal to 10. That is 2 into A is minus 2.5 into S is 1. So V square is equal to 10 minus 4 point times R. V square is equal to 5 R. This implies that V at C is the square root of 5 meters per second. So this is the way that we are going to solve this question, that speed at C with the friction from B to C is root 3 over 2 is going to be calculated equal to square root of 5 meters per second. Since the particle comes to the second part, the particle at C becomes at rest, then find the value of the coefficient of friction for this part. So we will solve it again for the second part. That is 30 degree. This is position A, this is position B, this is position C, 1 meter distance between these two, and friction is there 30 degree. Here friction is function of zero, and we have calculated the speed at B there equal to square root of 10 meter per second. And for speed at C is 0. And the distance between these two is 1 meter. So we can use this equation of motion. 2as is equal to v square minus u square, where 2as is acceleration we don't know, distance is 1 meter, v square is 0 square minus u square, which is v, that is the initial speed of that particle v. So that is minus 10. So a is equal to minus 5 meter per second square. So this is the first part of the second part of that, that acceleration at this position is equal to minus 5 meter per second square. Now you are going to calculate the speed at C, sorry, coefficient of friction. We know that driving force minus resistive force is equal to MA. Driving force at this point B is basically equal to mg sin theta minus frictional force is there F, because at this position, so this is the frictional force. So mg sin theta minus F is equal to m a dash, which is a dash here. So mg sin theta minus mu r is equal to m a dash. So mg sin theta minus mu r is basically equal to mg cos theta, and that thing is equal to m a dash. So m is common. So that thing is equal to g sin theta minus mu g cos of theta is equal to a dash, or mu g cos theta is equal to g sin theta minus a dash. Now we will put the value of mu there. So mu is equal to g sin theta minus a dash over g cos theta. Now g is 10, sin theta is half, minus a dash is minus 5 divided by g is 10 and cos theta is root 3 over 2. So this thing is equal to mu is equal to 5 plus 5 over 5 root 3 over 2. So this is becoming 5. So that thing is equal to 10 over 5 root 3, or 2 over root 3 is the coefficient of friction. We can even write this thing as 2 over root 3 into root 3 divided by root 3, and that thing is equal to 2 root 3 over 3 is the coefficient of friction of this particle when this is going to be addressed at the position C there. So this is complete solution for this question number 9 for this mechanics.